Welcome back, students. In this video, we're going to cover Lesson 3-1. This is the first topic in Module 3. This is Conjectures and Counterexamples. The benchmark for this lesson is LT 4.10. So this is, see, it's a little different. So this is going to be a lot of words throughout Module 3, more than the numbers. I understand this is a math class, and but we got a lot of words to deal with here lately, or recently. We're going to be dealing with them. All right, give me 1 second. I have misplaced my pen. I'm going to pause. Okay, sorry about that. Lost my pens. Clocks were going off. You can't hear it because I think I've got things situated, but. Anyway, all right, so key vocabulary. Let me write in my words here. I'm just going to go ahead and write the next word since I'm here. That way I'm out of the way for a few minutes. All right, so inductive reasoning. That's the process of reaching a conclusion based on a pattern of examples. Okay? And you'll see what I mean here in just a second. And the next vocabulary is a counterexample. So a counterexample is an example that contradicts the conjecture. So when you come to a conclusion based on inductive reasoning, you are going to write a conjecture. It's a statement. And a counterexample is anything that can contradict that. Okay? So if you were thinking about science class, this would be you're disproving a hypothesis. So think of it that way. All right, we're going to scooch up. All right, so example 1. Write a conjecture that describes the pattern in the sequence. Then use your conjecture to find the next term in the sequence. All right, so the first thing we want to do here is read what we have. The information they give us is appointment times. So 8:30 a.m., 9:15 a.m., 10 a.m., 10:45 a.m. So what pattern do we notice? Hopefully you noticed. So from 8:30 to 9:15 is 45 minutes. From 9:15 to 10 is 45 minutes. From 10 to 10:45 is 45 minutes. So our conjecture would be that appointments are 45 minutes apart. Okay, so based on that conjecture, what would be the next term in the sequence? So 10:45, so you add 45 minutes to 10:45, and you're going to get 11:30. And just for good measure, we go again, so 45 minutes from 11:30 would be 12:15. Okay. All right, so example 1, check. So you're going to look at these numbers and see the pattern. You're going to write a conjecture based on the pattern, and you're going to go ahead and give the next, it says the next term, but to make sure you're listening, let's get the next 2 terms. Okay? I'm going to scooch down the page. All right, example 2. Make a conjecture about the sum of the squares of 2 consecutive natural numbers. List or draw some examples that support your conjecture. Okay, so it's asking us to write a conjecture is a statement. So the sum, you think mathematically. So what do we do to numbers to get the sum? We add them. Okay, so we're going to add 2 numbers. So we're going to add the squares. So we're going to square 2 numbers, but 2 consecutive natural numbers. So consecutive is just, we'll say 1, 2. So 1 plus 2. So we're taking the sum. So we're adding the sum of the squares of 2 consecutive numbers. So 1 squared plus 2 squared. Well, 1 squared is 1. And 2 squared is 4. 1 plus 4 is 5. Sorry if you hear my phone ringing. I got some spam and I can't get to it. All right, so let's pick two more consecutive numbers. Let's say, we'll say 9 and 10. Okay, so 9 squared and 10 squared. I know I wrote the equals, but we're going to go down here. So 9 squared is 81, and 10 squared is 100. If I add these two together, I get 181. All right, let's go one more. 11 plus 12. All right, so 11 squared would be 121. 12 squared is 144. We add them together and we get 165. So what do we see? We see that the sum of the squares of two consecutive natural numbers are always odd. See, 5 is odd, 181 is odd, 65 is odd. So the conjecture we would write is the sum of the squares of two consecutive natural numbers is always odd. Okay, makes sense. All right, so over here, excuse me, they make it a little simpler for you on the check. So you're going to write a statement, write a conjecture, make a conjecture, excuse me, about the sum of two odd numbers. So you're not squaring anything. You're just you're taking the sum of two odd numbers. See what you get. Write your conjecture. Let's flip over to page 2. Give me just a moment to reposition. All right. Top of the back page of 3-1. Example 4. The table shows the average price of gasoline in the United States from the years 2010 to 2018. Make a conjecture about the price of gasoline in 2019. Explain how this conjecture is supported by the data given. So the first thing you need to do is figure out the data. What are you dealing with? So what I would do, so we have 9 years here, 2010 to 2018, that's 9 years, and they want to know what 2019 is going to be. So we'll just go 2019 with a question mark here. Okay, well, what I would do is figure out the average here. Let's see what, because it's all over. You can see 214 as high as 358, 368. Of course, I didn't bring my calculator. So we're going to try to make this work over here. You're just going to have to trust. Well, you'll see I'm typing in the right numbers. All right, so 284 plus 358 plus, where'd you go? 368 plus. If you guys are looking at the page and looking at what I'm typing, you should see that I'm doing it right. So this is the total. We're going to divide it by 9 because that was 9 years. All right, so you see 299.44. So basically $3 a gallon. So we're going to say that 2019 is going to be roughly $3 a gallon, and our conjecture is going to be that the price of gas should be around the price of gas in 2019 should be around $3 a gallon. Okay? Simple enough. All right, example 4 check. So just real quick, it says that these numbers, the exposure time cuts in half. So, and it wants it in a decimal. So my recommendation is to take it from here, half is 0.5, a fourth or a quarter is 0.25, and then use your calculator, divide by 2. That just makes it a little easier. We had some trouble in class. Okay, example 5. Find a counterexample to show that each conjecture is false. All right, so for A, if n is a real number, then negative n is a negative number. Okay, so some of you guys get bent out of shape over the letters in math. Well, just remember that n, or any letter, is a placeholder. So what that is saying is, so we're just going to put a number in here. Let's say we're to prove it true. So if n is a real number, negative n is a negative number. So if we made n 2, then negative n would be negative 2. But what if n is negative 2? Then negative n would be positive 2. So if n is a real number, all right, so if n is negative 2, then negative n is positive 2. So this is your counterexample. All right, down here, if ABC and angle DBE are congruent, then angle ABC and DBE are vertical angles. All right, so they want you to prove that this is false. Well, vertical angles, as we know, are congruent, but they don't have to be vertical angles to be congruent. They can just be equal or have the same measure. So the counterexample would be ABC is congruent with angle DBE because they have the same measure. So to be congruent, that means, congruent and equals means basically the same thing. Equals are for numbers. Congruency is for shapes. But if they're congruent, their measures are the same. They don't have to be vertical angles for that to be true. I hope that makes sense. Do the same here. You're going to plug in whatever they give you in here and tell them if it's true or false. And then think about this one. I'm going to go down here to the bottom. We have, so a counterexample is an example that contradicts the conjecture. Remember, that's the statement. Number 2, I'm going to let you guys answer. Number 3 at the bottom. All right, so how many counterexamples are required to disprove a conjecture? All right, so think again about science. How many times do you prove a hypothesis false, or that it makes it false? And the answer is 1. You only need 1. And explain your reasoning. I mean, it's because you only need 1. I mean, that is really the answer. All right, if you guys have any questions, let me know. I know this went kind of quick. Hopefully, we didn't have any problems except for the one I kind of pointed at. But if you have any issues, send me a message. Until next time, have a good night.